Hello everyone, welcome to my YouTube channel, the DSA Lab. I am Sasindi and today we are going to explore two fundamental data structures, stacks and decks. If you ever wondered how data is organized and accessed in programs, this video is for you. We will cover what stacks and decks are, how they work and how to implement them in Java. By the end, you will have a solid understanding of their differences and uses. So let's jump right in. Let's start with stacks. Imagine a stack of plates. You can only add a new plate to the top or remove the topmost plate. That's exactly how a stack works in computer science. A stack is a collection of elements where you can only add or remove items from one end, the top. This is called the LIFO principle, last in, first out. For example, if you push A, B and C onto a stack, the first one you will pop off is C, then B and finally A. Stacks are used in many applications like managing function calls in programs or handling the undo feature in the next editors. This Java code demonstrates the basic operations of a stack data structure using the stack class from java.util package. Java.util package. So this imports the stack class which provides the stack functionality. A new stack of integers is created and the push method adds elements to the top of the stack. After these operations, the stack contains 10, 20, 30 with 30 at the top. The peak method returns the top element of the stack without removing it. The pop method removes and returns the top element of the stack. After popping, 30 is removed and the stack becomes 10 and 20. Here's the output. This shows the top element of the stack before any elements are removed. This confirms that the pop operation successfully removed and returned the top element 30. This shows the state of the stack after pop operation. The stack now contains only 10 and 20 with 20 as the new top element. Now let's move on to the decks. Short for double-ended queues. Unlike stacks, decks allow you to add or remove elements from both ends. This makes them incredibly flexible. You can think of a deck as a line of people where you can join or leave from either the front or the back. This flexibility means decks can be used as both stacks and queues, depending on how you use them. Here's how a deck works. Imagine a line where you can add or remove people from both ends. In this deck, we have the numbers 5, 12, 7, 21 and 3. At the front, you can add a new element using add first or remove the first element using remove first. At the rear, you can add a new element using add last or remove the last element using remove last. So it's like a super flexible queue where you are not stuck to just one end. So deck is like a super flexible queue where you are not stuck to just one end. This Java code demonstrates the basic operations of a deck. Let's break it down step by step. The code imports the deck interface and the array deck class from the java.util package. Array deck is a resizable array implementation of the Deque interface. And this, a new Deque of integers is created using array Deque. And this adds the integer 100 to the front of the Deque. And this adds the integer 200 to the end of the Deque. This adds the integer 300 to the end of the Deque. After these operations, the Deque contains the elements 100, 200 and 300. This line prints the current state of the Deque, which is 100, 200 and 300. And this removes and returns the first element 100 from the Deque. This removes and returns the last element 300 from the Deque. So let's see the output. This shows the Deque after adding the elements 100, 200 and 300. The first element 100 is removed from the front of the Deque. The last element 300 is removed from the end of the Deque. After this operation, the Deque would be empty. Here's the quick difference between stack and Deque. A stack only lets you add or remove from the top. It's LIFO, last in, first out. Think of it like a pile of plates. It's great for things like undo operations or function calls. A Deque on the other hand, lets you add or remove from both ends, front and back. It's super flexible, can work like a stack, a queue or both. You will see it in sliding window problems or when you need to implement both stacks and queues. So if you only need one end, go for a stack. If you need both ends, a Deque is your best friend. So how do you choose between a stack and a Deque? Use a stack when you only need to access the most recent element, like function call management or undo operations. Use a Deque when you need the flexibility to add or remove elements from both ends, such as in scheduling algorithms or sliding window problems, like that. So to sum up, stacks and Deques are both powerful data structures, but they serve different purposes. Stacks are simple and efficient for LIFO operations, while Deques offer the flexibility of ascending both ends. If you found this video helpful, don't forget to hit the bell icon and subscribe for more DSA content. Thank you for watching, and I'll see you in the next video. Until then, happy coding!